So in this problem, we have an industrial pressure washer system, and this equipment over here is a pump. So we have the values of X, Y, and Z. Also, we have the flow rate equal to 3.4 cubic feet per second. And we know the hose diameter is 3 inches. If we assume that the head loss is 4 feet from point 2 to the nozzle, what we're going to find is the pressure at point 2 if the jets from the nozzle is 1 inches in diameter. So in other words, we're going to find pressure at point 2. In order to do that, in order to find out the pressure, and since we have the value of flow rate, I'm going to write the energy equation between point 2 and point 3, which is at the outlet of the nozzle. Okay, so energy equation between point 2 and point 3. If I write the energy equation between the 2 points, it would be simply plus HL. Now see if we can simplify this a little bit. We know that the value of HL is equal to 4 feet, so that's the value that we have. Also, we know that pressure at point 3 is 0 gauge pressure because it is in contact with atmosphere. Now, we need to calculate the value of velocity at point 2 inside the pipe and velocity at point 3 outlet of the nozzle, right? So I am going to write the velocity values like this. So velocity at the nozzle, which is equal to velocity 3, would be Q divided by diameter of the nozzle to the power 2. So Q is 3.4 cubic feet per second, and this would be P over 4. Diameter of the nozzle is 1 over 12. It's 1 inches divided by 12 to be to convert it to feet. Okay, and the value of velocity at the nozzle would be 623 feet per second. And now if we calculate V velocity 3 squared divided by 2g, this would be equal to 6034 meters. Okay, now we need to do the same thing for velocity in the pipe, which is V2, right? If you write down the equation, it would be exactly the same thing as the equation for velocity at nozzle. The only difference is that instead of having dn, we have d pipe or d hose to the power 2. When you calculate that, the velocity would be equal to 69.26 feet per second, and velocity 2 to the power 2 divided by 2g will be equal to 74.50 feet. Okay, now I calculated the values for velocity head, and also this should be feet as well. Okay, I'm gonna plug them into the energy equation and write down the energy equation. So I have P2 over gamma over here. Perfect. And finally, I have the value 9 plus 4. Did I forget Z2? Oh, yes, I forgot Z2 over here. So let me, this should be plus 5 feet. Why do I have 5 feet? Because take a look at, this is my Z. If the datum that I consider is this line, so this is my datum, Y is my Z2, and Y is equal to 5, so I have it over here. And then this should be equal to this is equal to 9, and then 4 is my head loss. Find value of P2 over gamma is equal to 5968 feet, which means that P2 is 5968 times 62.4. The units for that is pounds force divided by cubic feet. And then this is optional, but if you want to convert it to inches, then you will write basically the conversion between squared feet to squared inches, and P2 will be 2590 psi. Okay, so this is how you find pressure at point 2.